Okay, welcome back. This is chapter 1 and 2 in the book, so please do have the book handy. The way I do this is I'm just going to talk to you. I'm going to go through my lecture notes that I have to make sure I covered everything, but there's not going to be any slide presentation, so you're just going to have to pay attention and take notes, right? Okay, good. So let's begin. So on page 1 of the book, it talks about beginning Android and Java. That sounds like us. A brief history, 4 guys put together Android Inc. in 2003. It was kind of a surprise or a think tank kind of a thing. No one really knew about them. They just magically appeared one day and it was like kind of a surprise. Google ended up purchasing the whole company in 2005. They created a thing called the Open Handset Alliance in 2007. What that basically meant was that they were going to license this stuff to developers of, for manufacturers of phones to use. So they came up with this open alliance, meaning everyone could kind of play and they weren't really going to be charged for anything. And so if you were a manufacturer of cell phones, you go, hey, you mean you're not going to charge me for the operating system? Woohoo! I don't have to develop any of that stuff? Wow, that sounds like a lucrative idea to me. So it kind of sort of took off. The first Android phone, in the US it was called the G1. It was actually called something different in other countries. It was in October 2008, so not that long ago. So the idea of, hey, I give away all this stuff, I can give away Android to the developers and the manufacturers. How am I going to make money? You make money by selling the apps on the Google Play Store. And then, of course, that requires you have some sort of an account with them, with Google, to be able to go purchase these apps. That's why they make their money. They don't make their money from selling the operating system. Okay, so on page 3, they talk about the stumbling blocks to getting into this. Well, first is, it pretty much requires you have a halfway decent understanding of the Java language, okay? And that is a prerequisite for this course. I am going to kind of go gentle on you and review a bunch of stuff. And one of the weird things is there's no need to install a separate Java development kit, the JDK, like we've done in other things. Like when we were installing NetBeans or something like that, we had to install the Java development kit. Well, this kind of comes with it. So they didn't want to have, they want to kind of lock down which version they were using. So you could go over here and do Java applications all day long, but you're not going to be messing with the version of Java that was installed in. So they separated them. So if you're a Java developer writing for Windows and you're a Java developer writing for Android, you're actually using 2 different copies of the JDK. Okay, so on page 4, they talk about how this all works. In the Java world, when you compile something into what's called intermediate code or bytecode, it has a .class file extension. You guys halfway remember that? So that was called bytecode. And then they use this thing called the Java virtual machine to convert the bytecode into whatever the heck you're running on. For example, if you're running on a PC or if you're running on a phone, it does the translation, the final translation. So it was a 2-hop deal. Your source code got turned into this intermediate code, then intermediate code got by the Java virtual machine got converted over to the real executable. That's kind of sort of the way it is here, but at the time they were doing this, the Java virtual machine thing was under some sort of a licensing agreement. So they came up with another one, and they called theirs the Dalvik virtual machine. Dalvik. Don't know. I read some articles about whether the approaches were similar and which ones were better. And to tell you the truth, it's kind of a toss-up. On certain applications, using the traditional Java virtual machine might have been a little bit faster. And then in other scenarios where it's not. So there's probably no real definitive answer on which one would have been best to use. But it doesn't matter. They chose to use Dalvik. So our code gets packaged into a thing called a package. So here's what it kind of sort of looks like. So our project, we use Java code inside our Studio Guy, and it produces a thing called Dalvik executable. They pronounce their acronym for it is called DEX. So a DEX file plus all the resources gets put into an envelope, a container, called an APK, an Android package. Okay, so an Android package is kind of sort of like a zip file that it contains all the executable code and all the resources. And then that gets transferred over to your machine, and where normally it would be the Java virtual machine, now it's the Dalvik virtual machine that spins it up to whatever the heck your phone is using, and then it runs. Okay, so the Java virtual machine and the Dalvik virtual machine, don't get those terms too crazy, because we use the term virtual machine in a lot of different ways. For example, I tend to use virtual machine a lot when we're talking about, installing, VMware or Hyper-V, those kind of things are VirtualBox, okay? Those are completely different uses of the term. Java virtual machine and Dalvik virtual machines are code translators, okay? They're not emulators or anything like that. And it's kind of sort of sad that we use those two terms, virtual machines, in two completely different contexts. It just makes things complicated. Okay, so the DVM, the Dalvik virtual machine, runs on a specialized version of Linux. Yeah, Android is actually based upon Linux as a core, not the entire frickin' Linux operating system, just the bits and pieces that it needs, the core pieces that it needs. And then, of course, Dalvik can get to all sorts of things through this Android application programming interface. So all these libraries and all these hardware and stuff that the Dalvik virtual machine can run down and grab a library, or grab the accelerometer or the GPS location or whatever else kind of hardware devices that are on there. Okay, on page 5, they start talking about the Android API. So Android Application Programming Interface is basically just a bunch of libraries. It all got installed when we were installing, so we don't have to deal with it. But there's many different versions, because Android is got, lots of different versions. Lots of different versions. We're talking, 30 and 40 different types of application programming interfaces out there to choose from. I kind of pick, the latest one to deal with. But if you have an older machine, you're going to have to pay attention to what API level it's at. Now, we start off, if you recall from the install, it went by really, really quick. It said, what is the minimum API level that we're accepting? And it defaulted to 16. Okay, don't worry about what that number means. It's just the 16th one. We're currently at 30. Okay, so that tells you, and they say that 90. If you pick 16 as your minimum API level, your target level, that means that'll cover about 99% or 98% of all the devices out there. There's a cool chart you can go to, but that shows what percent of each one of the API levels are available. But I'm going to leave that to you when you do your writing assignment. Okay. So let's continue. So on page 6, you start talking about object-oriented programming, kind of in the abstract. And basically it has an awful lot to do with code reuse and making your life as a programmer easier. That's basically what object-oriented programming is all about. So code reuse basically means I can start with some existing code that kind of sort of fits my needs, and maybe I can use this thing called inheritance to just take that code and then just make some minor tweaks to it. It's almost what I need, but I just need these extra things thrown on. Well, rather than starting from scratch, which would be a hell of a lot of work, I'm just going to inherit from something that's close and then make some tweaks to it. So that's a cool thing, right? That's part of object-oriented programming. The next one is called, I'm trying to build something, but I don't want to make it so dang complicated that the person who uses this thing that I'm building has to know absolutely everything about how it works. Now, if you're a single programmer, right? And you're the only person on the team, or there is no team, well, then this step may not sound like it's very important. But on the other hand, if you're working in a team with 4 or 5 people, and Bob over there in the corner is producing this thing that you need, you don't have the time or energy to figure out the intricate workings of this thing. You don't want to do that. You just want to be able to say, hey, Bob, how's this thing work? And the guy says, well, you just give it this, this, and this, and then magic happens, and it'll work. In other words, you don't have to understand how it works to be able to use it. The analogy that I use is you don't have to understand how an internal combustion engine works in order to drive a car, right? I mean, you jump in the car and you start it up and drive off. You don't have to understand how it works. Well, that's what we're talking about. Anyway, that's called abstraction. So abstraction means I'm deliberately hiding some details of how things work because you just don't need to know that. Now, abstraction is not about keeping secrets. It's about I don't want to know how an internal combustion engine works. So it's not like, oh, I'm trying to keep it secret. No, it's not a secret. I just don't want to know. Okay, cool. The next one is I need to break things into smaller parts. I got this monstrously huge task I'm working on and this mind-numbingly amount of stuff to deal with, and I can't keep it all in my head. So you break it up into manageable chunks. Like, this is the part where you ask the user for information, and this is the part where you do the calculations, and this is the part where you do the reporting, and this is the part where you do all these little pieces. Okay, that's called functional decomposition. That means taking a big task and breaking it up into smaller tasks. And again, it helps you focus. When you do functional decomposition, it allows you to only talk about this one tiny little piece, and to heck with all the rest of these pieces, because I can't keep all that in my head. But I can think about this, so that's what that's for. Now, after you've functionally decomposed the problem, then you need to bundle the related things together, and that's called encapsulation. Now, encapsulation is kind of cool, because what it's done is it grabs all of the things that you need. For example, I don't know, you're doing a report. So the report's going to need like the title of the report and whatever heck's, the data that's going to show into it. It's going to have to know, how it's formatted, if it's, like if it's going to a printer, all those kinds of things. And so all that information about the printer and the orientation and the title and the page count, all that is stored inside that one piece. So the people who are writing to the report don't have to understand any of that, right? So we're kind of doubling back to this thing about abstraction. When I bundle all the actions and data together, that's called encapsulation. So this thing called a report. So it's got actions like print, and then it's got all this data, like the title and the page number and all and the orientation of the printer, all those kinds of things. And they're all bundled together, and that's called encapsulation. Okay, so we're going to hear this term a lot, talking about classes and things of that nature. So a class is typically one of those things that you build. And there's a term that we're going to use an awful lot. It's called an object is an instance of a class. Yes, you're going to hear that a lot. So, in fact, this term instance, they actually make a verb out of it. It's a horrible term. Where I instantiate. I don't think that'll pass spell check because that's kind of a weird made-up word. But I can instantiate a class. In other words, make an instance of a class. Okay, we're coming up on the 15-minute mark, so you guys know how this works. I'm going to stop the video and then come back in part 2.